So we can just try and solve. I want us to do this first one since the answer is there so that we can compare. So just keep in mind that we are solving the NLPP using Lagrangian method, which you've said is the one that is with equality constraints. So when you're solving these things, there are some steps that you're required to follow. Just know that it has some steps. Your lecturer he has about 3 steps. But I think I will do those the 3 that he has are highly summarized. So there are some steps there that you might wonder what is he doing, because it's just getting answers and you don't know where they're from. So mine will be, I might do 4 or 5 steps.
That guy, he's what can I say? He's a mathematician. So sometimes even when he teaches, we're just left staring. How to simplify. In fact, he had to
It's because you see him, he does them every day. So that's why him, when he's doing them, is just thinking, oh, you guys. So he's thinking you understand. So I'll try and mine will have more steps just to make it more clear. So the first step, we are coming up with a Lagrangian function. I'll say come up with a Lagrangian function. Recall how the function looks like. We just had a look at it. Yeah, so this second part is what we need to come up with first, the lambda h. So, and to do that lambda h, we need to dealing with the constraint. So the first thing I'll ask you to do is equate the constraint to 0. The constraint is a subject 2.
Yeah, the h.
So we are taking the x1 plus 5x2 equals to 7. So equating it to 0 is same minus 7. So because now it's like we're taking the 7 to the other side. Right. So it's x1 plus 5x2 minus 7 equals to 0. The next thing is to introduce lambda. How do you introduce lambda? You multiply
the constraint by lambda.
The constraint with lambda. So what does it become?
So it will become lambda x1 plus, okay, you put lambda into bracket x1 plus 5x2 minus 7. You multiply it, you open. So you get lambda x1,
so when you open,
lambda x1 plus lambda.
I will prefer you start with the x.
Or x1
whatever you're giving me is correct, but I prefer you say x1 lambda plus 5x2
lambda minus 7 lambda.
Minus 7 lambda. So this is that second part of the objective function. So what do you do with that part?
So this part, so you will do L is equals to 6x2 squared plus 5x squared 2 minus x1 lambda plus 5x 2 lambda minus 7x. So that will be your L.
So now you're formulating the Lagrangian function. You're taking this to the objective function, you subtract the Lagrangian. So whatever you had as the objective, that was the 6x1 squared plus 5x2 squared. I subtract whatever I have here. Now, when you're subtracting, whenever you're putting a minus sign after a number of unknowns, it's very important to take care. Why? Because
to take care,
like to watch out. You need to watch out because that minus sign
will change.
Normally affects how the equation comes out. So technically speaking, when these brackets are opened, it should result in a new equation. Because when you multiply those signs with the negative, they might change. Not even they might, they will change. So here it is, the minus times the plus is the minus, but this minus times this plus is, minus times the plus is what? 8 is minus, and here minus times minus, it becomes plus. Okay. Now you have your Lagrange function. Once you've formulated it, you can move to the next step. So, and what are you doing in this second step?
We differentiate.
But how are you differentiating?
The rules, based on the rules.
Do you know what the name of the rule?
To the name of the rule. I don't. No. What's the name of the rule?
It's known as partial. It's known as partial differentiation. That's how I'm written. Partially differentiate. The thing is just simply put is that whenever you are differentiating a function that has more than one unknown, whenever you're differentiating a function that has more than one unknown, you're doing partial differentiation, meaning you're differentiating in terms of the number of unknowns. So if I have x1, x2, and lambda, I have 3 unknowns. So technically speaking, I am doing dx1, sorry, dl dx1. I am doing dl dx1. That's the first differentiation.
DH.
Come again?
It's DL dx1.
Yeah, it's dl because you're differentiating the Lagrangian function. So it's dl dx1, dl dx2, and dl d lambda.
DL dx1.
So when you do dl dx1, what do you get?
You
You're
do
differentiating
DL
in terms of x1.
So DL, so you look at the L function, which is 6x1 squared plus 5x squared minus x1 lambda minus 5x lambda plus 7. That's the one we're looking at. So it will be L dx1. So we are differentiating the x1 function. The x1, it's a variable, or it's a constant. So it will be,
It's a function.
so it will be 12x1 minus lambda. It will be 12x1 minus lambda.
And do you know, you understand where the 12 has come from? Where the lambda has come from?
We drop the power.
So what about the second one?
So the second one will be dl dx2, which is going to be 10x minus
10, it's 10x what?
10x2 minus 5 minus it's squared s minus 10x2 lambda.
No, it is 5. It's whatever you're saying. 10x2 minus 5 lambda
Minus 5 lambda
equals to 0. 10x2 minus 5 lambda equals to 0. You understand why it's 5 lambda?
Yes, because the others, the 7 lambda does not have x2.
What about the LD lambda?
It will be lambda minus 5 lambda plus 7.
There is no lambda. You're starting with the x1.
So x1 minus 5x2.
Actually, minus x1 minus 5x2 plus 7. When you're differentiating this function, it is 1 times minus x1, so it's minus x1, and then minus 5x2, lambda goes, and then here remaining the plus 7. The only thing is that to get rid of the minuses, that question actually reverts back to the one that you equated to 0.
It reverts back to?
To the one that you equated to 0. Do you remember here when you're equating the constraints to 0? This one that was x1 plus 5x2 minus 7. So this question, this equation is actually similar to when you differentiate the question here at that time. That is if I was to get rid of the negative. And this can also be written as still x1.
Wait, is the TV too loud? Someone watching TV.
I'm here. It's in the distance.
It's far.
I can hear, but it's far. So this is also the same as saying x1 plus 5x2 is equals to 7. So this is exactly the same as what we had originally. Can you see that? x1 plus 5x2 is equals to 7. So,
yes.
So just note that whatever you normally get when you differentiate the third equation is normally the same as whatever you had originally as the constraint, or the constraint equated to 0. So that is equation 3. You have done partial differentiation of the Lagrange function. So moving to the next step, what are we required to do next? I think we're now required to solve for the values. Solve for the values of the unknowns. So
that's step 3.
The values of x1, x2, and lambda.
x1, x2, and lambda.
So this is where now you have to, depending on what kind of equation you have prior, will determine the method that you'll use here. But these are technically speaking simultaneous equations. So there are different ways of solving a simultaneous equation. In this particular case where we just have actually 3 unknowns, we can start with the last one, equation 3, and we can try and use this one to find the values of x1 and x2, see whether they can be beneficial to help us solve. No, just a second. No. No. Let's just start with the first one. We'll start with the equation 1. Since it's just 2 unknowns equals to 0, as well as equation 2. So beginning with equation 1, from equation 1, you can try and formulate x1, make x1 the subject. So from equation 1, we can have x, it's like taking the lambda to the other side. So we'll be left with x1 is equals to lambda over 12. Can you see that? We do the same for the equation 2.
12x, so 12, so x1 is equals to lambda over 12.
From equation 2, I do the same thing. I make the x2 the subject. So I'll move everything else to the right. So x2, when I move the minus 5, it becomes positive. So it is 5 over 10 x2. 5 over 10 is the same as saying a half. Oh, a half lambda, or
so x2
yeah, or lambda over 2.
x2 is equals to, but the x, does the x disappear?
Come again, the x. Now, so you still have the x1 and x2. Now, when we get here, personally, I find it easier to operate in terms of decimals rather than fractions. This is the lecturer was using fractions to proceed. I find it more complicated. So according to me, if I was to rewrite x1, I would rewrite it as a decimal. Say that x1 is equals to 1 over 12. It would be what?
0.08.
I'll write it as 0.08. I think I use 3 decimals, 3 lambda. And x2, I'll write it as 0.5 lambda. But let me just, this is, yeah, so it's just 0.5 times 0.08. Let me get rid of the 3. Let me just have it as 0.08 lambda. So if I have the values of x1 and x2, I can use them to help me gain
value of z.
Yeah, the value of not z first of all. I want to get the value of lambda first.
Oh yeah, lambda.
So to get the value of lambda, what can I do? Where can I substitute?
x1 plus equals to 7.
So now, since I've already used equation 1 and 2, I can take equation 3. So from equation 3, I can substitute the values of x1 and x2 and see what I am able to calculate. So I have substitute x1 here. This is 0.08 lambda. Plus 5 multiplied by 0.5 lambda.
So it gets 0.583 lambda is equals to 7 over 0.583.
When you're saying it is what?
It's 12.
When you solve those whole numbers, you get.
Oh no, sorry, I forgot to multiply by 5.
I have 2.58 lambda is equals to 7.
I made a mistake. 2.5.
Yeah, 2.58 lambda.
2.083. So you get 2.583.
So lambda is equals to
2.7.
2.71.
Because working with those equations is hard.
The equations can confuse you a bit, but it's the same thing. I don't think he will give you a wrong just because you're using decimals. Just be careful with the rounding off of the numbers. Just as you've seen, we are going to the Supreme Court because of decimals.
Yeah. This one gets
Anyway.
actually.
So
yeah.
We have the value of the unknowns. We have x1. Sorry, we do not have. Actually, we only have lambda. So now the lambda can help us get the values of x1 and x2. So we actually have this thing is erasing 0.08 lambda. So we can substitute this lambda into the values of x1 and x2 to get the values of x1 and x2. So x1 is equals to 0.08 times the lambda. 0.08 times the 2.71. What do you get?
0.2168.
x1 is equals to
0.2168.
0.2168. So you can say 0.22. What about x2?
13.69.
x2 we are taking
2.5 times 2.71.
0.5 times the
5.
lambda.
0.
See, x2 was a half. X2 was 0.5. So it's 0.5 times the lambda.
Oh, so x2 is equals to 0.5 times 2.71.
Yeah. What do you get?
0.6.
0.71. I'm getting 1.355.
1.3.
Yeah, which is I can say 1.36. So now we have the values of all the three of them. It's 2 equals to 1.36. So now the question is, when we get there, there's another step. It's a very interesting step where you need to determine whether the solution is maxima or minima. Just give me a second.